All right, guys. So I have the data's in these three lists. And so for list one, let's just look at what we're getting into here. I'm going to hit stat and go over to calc and do one variable statistics for list one. And let's see what I get. There are 20 data values. That's not big enough to use the central limit theorem. So I'm going to have to look at the graph to see if the graph is giving me an indication that the population is normal. Because as we know, if the population is normal, then the sampling distribution is normal, and we're okay using and basically the t star. Okay, so I'm probably going to need that mean and that standard deviation later in the show, but for now we're going to graph to verify the normal conditions. So I'm going to go to second and y equals and go to the first statistical plot menu, and let's do a histogram for L1. Okay, get the bar graph looking thing, put L1, and then once again to see this graph we're going to hit zoom, and stats is 9, so zoom 9. And so I'm just going to do a quick sketch of what I see here. There's one bar on the left, and then we got two that are, it's about twice as high as that one. And then there's one more that goes a little higher and a little gap, and then another one. Okay, for me, that's not an outlier. There's a gap, but that doesn't mean that's an outlier. I would need to see all of these together and one way off to the side. And it doesn't look perfectly normal. It looks heavy on this side and not very much on this side, so you might want to call it skewed left. But you guys, that's one big lump of data in one spot. That's good enough. Even if the population isn't perfectly normal, T procedures are robust, we're okay. Okay, so for the normal condition, I'm probably going to say verified here. But before I do, let's look at the box plot. So second and y equals, I'm going to hit enter, and I'm going to go look at this box plot. So hit zoom 9. Let's see what the box plot looks like. That is almost perfectly symmetric. I mean, I'm seeing the median is just right in the middle of that box. The two whiskers are about the same size. I don't see much of a reason to call this skewed at all. And the normal probability plot, I wanted to throw this in because you guys haven't seen it in a while. And so let's go second and y equals and hit on. The normal probability plot was the last one. It's the sixth option. So I'm going to hit enter. And when I hit zoom 9, the idea of the normal probability plot was if the form is approximately linear, then the distribution is approximately normal. And so I see a little bit of a curve, but we got this other point. That's that gap we were talking about before. And this, in general, this form appears to be linear. I don't see like where it started and then it curves like a logarithm, or I don't see it taken off like an exponential function. So I'm going to just do my best sketch here. It doesn't have to be great. There you go. There's my graph. And what I'm saying is, as an overall pattern, that's linear. So my normal condition, I'm going to say the population may be normal. And so I'm just going to say verified. I have verified the normal condition. I can use the T star in my confidence interval. Okay, let's do the same trick for data set number 2, L2. So I'm going to go second and y equals, or start the whole thing over. I'll hit enter to go to that plot, and then I want to do a histogram first. But I'm going to change this to list 2, so we're taking a look at the second set of data, and hit zoom 9. Well, now that doesn't look normal at all. That's not even close. This is a strong skew without question, and there's no way I'm going to be able to verify the normal. So this is the population is skewed, not verified. I'll just write not verified. I mean, you guys would be writing sentences, so you would say something like, so I cannot verify the normal condition, right? Let's take a look at the box plot, see what a box plot looks like when it's all jacked up. Second and y equals, hit enter, and I'm going to go change this to a box plot, and it's still for L2, so hit zoom 9, and let's see what a skewed box plot looks like. There you go. That second whisker is way off to the right. Sorry, I can't find a good place to put the thing. So just drawing what I'm seeing here. I'll bring it back up in a second, but that's kind of what the box plot looks like. That right whisker is way off to the right compared to that left really short whisker. They're not even close. And the median's not too far off center, so that's not what really tells me that this is skewed. It's this right here and how tiny that is. Okay, and then the normal probability plot. Hit second and y equals, and then we're going to go get a normal probability plot. There we go. And I hit zoom 9. I'm going to see some kind of a curve in here somewhere, probably off on the right side, yes? So it starts here and then it curves off to the right. See what I mean? There's a couple of little spaces for little gaps, but that's not the big concern. The big concern is we start vertical and then we take a right turn. That right there is telling me that it's skewed. And the fact that I have gaps off to the right tells me that it is skewed to the right. So my normal probability plot, just going to put a bunch of them going straight up. This is what I'm seeing, and then all of a sudden we look like that. So I can't draw a straight line through that. That is definitely curved. Population skewed. All right, let's try the third one. Back to the calculator. I'll hit second and y equals, and I'll go to the statistical plot menu, and I'm going to do another histogram. So go to the histogram and hit enter, and this time I would like it to be L3 because I put that data set in L3. Now I'm going to hit zoom 9 and see what happens after I take a drink of water. There you go. Zoom 9. I only see one big tall bar, and I see other bars off to the right, so I'm a little skeptical at first glance. However, what don't I see? I don't see outliers, and I don't know that I can call this strongly skewed. It looks like, if I had to name it, I would say this might be skewed to the right. I wouldn't call it symmetric, but I definitely wouldn't call it strongly skewed to the right. It's got some skew to it. And t-distributions can be okay and give reasonable results if we have some skew. Let's look at the box plot and see what that looks like. So we go second and y equals, and let's see how, hit enter. Let's see how bad this box plot looks. I hit enter, and this is going to be list 3 again, so hit zoom and 9, and let's look at the box plot. So the center is off, and the whiskers aren't the same, but you see they're not really distorted like that last one was. So this is kind of borderline for me right now. Let's do the normal probability plot and see what that looks like. Second and y equals, hit enter, and I'll go off to the right and I hit enter. It's going to be for list 3, so a normal probability plot. Again, it needs to look like a normal shape, linear shape for me to say it's normal. So I'm going to zoom and 9, and we'll take a look, and I'm going to draw what I have. So along the way, there's some bumps, right? Like it looks like it's not perfectly linear, but that means it's not perfectly normal. If I were to sketch an overall shape, I think I'm okay with it, right? I've got this big gap here, but I didn't see a big gap here creating outliers. If I want to see a gap for outliers, I'm going to see it here, or I'm going to see a really long whisker on the box plot. I'm going to say for this that the population may be normal. I'm going to say verified. I'm going to be honest with you that this one is on the edge for me, but I think I would say the normal condition is okay because we don't see any outliers and we don't see strong skew. All right, here's the book throws out this math calculation to get you a feel for whether or not it's too skewed. Ready? You do the one variable statistics and you get the 5-number summary, and look what we're going to do here. Find the maximum minus the median, and that would be the range for the top half of the data. Hope that makes sense. Then I'm also going to find the median minus the minimum. That would be the bottom half range. And then I would compare them. So if it's really going to be skewed way off to the right, then this max minus median would be way, way, way bigger than this. If it was skewed way off to the left, this would be way, way bigger than this, like more than 2 times bigger, right? Like a multiplier. So let's call these, I'm making this up. This is not from the book. I'm just making it up. Let's call them half ranges, okay? So for our last 3 examples, check the half ranges and calculate a 98% confidence interval. So we're going to do some work right here, okay? Let's go to L1. We have verified the normal condition. Okay, so let's see. I'm going to go over to calc, and I'm going to do one variable statistics, and I'm going to do that for L1. It gives me all kinds of stuff. So I'm going to write it all down. Okay, we have n equals 20. We have x bar is equal to 306.32. We have the standard deviation. Can I fit that in here? I think so. We have the standard deviation from the calculator is 36.2. The minimum, I gotta scroll down on my calculator. The minimum is 233.5. The median is 308.85. and the maximum is 374.6. Okay, now I want you guys to keep in mind, man, that's a lot of stuff that we just got from the calculator right there. I want you to keep in mind that we have verified the normal condition. We think that that one looked okay. So let's look at maximum minus the median. All right, that's going to be 374.6 minus the median is 308.85. Now this number in and of itself doesn't mean a whole lot to us. 374.6 minus 308.85. What do I care about? Half of the range, right? 65.75. What I want to do is compare it to the similar number from the lower half of the data. So now I'm going to go median minus the minimum and see what that one is. Okay, the median is 308.85, and I'm going to subtract the minimum, 233.5, and I get 73.35. Of course, if it was perfectly normal, this distribution, those would be perfectly equal. They're not, but they're kind of close. It's not like you multiply this one times 2 to get to that one. You see what I mean? Okay, then we were going to do a confidence interval. So let's see. That would be x bar plus or minus t star times the sample standard deviation over the square root of n. Okay, that's going to be 306.32 plus or minus. You guys got to start getting good at this, finding these t stars here. So I have n equals 20. It's the degrees of freedom 19. Go look it up in the chart. For a 98% confidence interval, I got 2.539. All right, and that's going to be times the 36.2, the standard deviation from the sample, over the square root of 20. And I put it in the calculator, and this is what I got. 285.77 up to 326.87. And because we verified the normal condition, we feel pretty good that that's actually got, you know, that with that process, with that graph, not this one, but the one on the other page, that, yeah, we think we would be right 98% of the time with that. Okay, for the second one, man, I took up too much space here. I got to get 3 problems in here. I'm going to have to write a little smaller, or maybe I just won't write as much stuff. Okay, so I'm going to go to list 2, stat, calc, 1 variable statistics. I'm going to do that for list 2, and I get all the information that I need. Okay, let me write some of it up here this time, maybe for this one. N is equal to 25. X bar is equal to 4.6. The sample standard deviation is 2.58. And then I'm just going to write down what the max and the median and the minimum are just to save room so this doesn't get ugly out of control, okay? So max minus the minimum, minus the median. The maximum minus the median ends up being 11 minus 4. It's equal to 7. The median minus the minimum. Now this is the one that we decided was skewed, right? We said this is not normal, number 2. So the median is 4 and the minimum is 2. So 4 minus 2 is only 2. Now keep in mind, I'm not comparing the actual distance for these two. I'm looking to see how different they are. This one, this is only 5 units apart, which is closer than this. However, I've got to multiply that times 3 and even more to get to that number. That's not the case over here. This is several multiples of this number to get there. That's how much bigger this one is than that one. That's an indication that it's skewed. So hopefully this makes a little more sense to you guys now. Then I'm going to go x bar plus or minus t star times the sample standard deviation over the square root of n. Okay, this time that's going to be 4.6 plus or minus the t star for a 98% confidence interval when degrees of freedom is 24 is 2.492. And that's going to be times the standard deviation 2.58 over the square root of 25. Now here's what I got. I got this as an interval, 3.31, comma 5.89. I used the formula and it's all good with one major exception. I can't be 98% confident in this number because this data is so skewed and is not big enough for me to guarantee the sampling distribution is normal, although that's actually pretty close to the central limit theorem. But since the population is skewed, I don't have any faith in that. Or I don't have 98% worth of faith in that. All right. The third one, I'm just going to write down what this stuff is. The max minus the median. The max minus the median is 13. And the median minus the minimum is 11. You can see right there, those are pretty close. And so I don't have any reason to discredit this graph as being something that could be a normal population. So I go x bar plus or minus t star times the sample standard deviation over the square root of n. And so that turns into 37.4 plus or minus. Look up the t star for a sample size of, oh wait, what's my sample size here? This one was 10. This one was only n equals 10. So degrees of freedom are 9. So it's going to be a bigger number, 2.821 times the sample standard deviation, which ended up being 7.66 over the square root of 10. I know I didn't write all that stuff down here, but I think you guys got the point by now, right? And so I get 30.57 up to 44.23. Okay, so I feel like you guys should be getting a pretty good handle on the T-star type stuff, as well as, you know, the normal condition and verifying it. So that's where we're at. I have one last thing to say before you take this test. And notice that I've bold-faced don't hate me here. Well, I'll tell you what. Why don't you just hit stat, just get your calculator out, and then you're going to be mad. I'm just going to say you're going to be mad. Hit stat, then arrow all the way over to tests. Now that is a menu we have not hit yet. So I'm going to go over to tests and do a T interval for list 1. Okay, so I'm going to go down to find that T interval. For me, it's number 7. Nope, number 8. T interval. Older calculator, it may say 1 sample T interval. I hit enter and it asks me, hey, would you like to use data or statistics that have already been calculated? Well, since we have data, let's just leave it on data and put L1 in for your calculator. Since I have data in my calculator, let's just use the data. And then the confidence level for those last problems was a 0.98, right? Yeah, you can see where I'm going with this. The calculator will come up with the interval for you. Let me go bring back the last page. We ended up with 285.77 and 326.87, 285.76 and 326.88. The calculator will do it for you. Okay. It's the same thing. We could do this for L2 and L3. You guys, I'll just leave you guys to check those on your own. And then, in fact, I have, let's go to page 522 and number 36. This problem is a p-hat problem. And they tell you that x equals 19 people said yes to whatever the question was out of n equals 172. And they asked you to make a 96% confidence interval. I don't think we need to read the book. I just want to show you how to use the calculator here. So I'm going to hit stat. So for this one, it's just a little bit different here. I'm going to hit stat. I'm going to arrow over to tests. And then I will do something called a 1 proportion Z interval. Ready? Look how it's different. So I hit stat, I go over to tests, and I look down for a 1 proportion Z interval. Now tests, that's next chapter. We can go by all the tests, and I'm going to keep going. There it is, a 1 proportion Z interval. It's all the way down to A on my calculator. And then it says, what is your X? I put in 19, and what is your N? 172, and confidence level 0.96 it asked me for. And so I calculate that, and just like that, I get 0.06 to 0.16, and it even tells me that p hat is equal to 0.11. So yeah, we could have been using that this whole time. But on the test and on the AP exam, you're definitely going to be asked to find little pieces of the confidence interval, like x bar or p hat. Like you're going to have to find a t star. The calculator just found those and did all that work to create this interval, right? But you're going to be asked to find t stars and z stars, and I'll ask you, hey, find the standard error for p hat. Find the standard error for x bar. So you need to know all the little components anyway, right? You need to know these formulas. and how to calculate them really well. You know, like you need to know really well how to go find the standard error for X bar. This, just in case you forgot, the standard error for X bar, that's the one that goes sample standard deviation over the squared n. That's what I'm referring to. I mean, I know you know that, but have you got that clicked together? And if you see standard error written out in a problem, will you recognize what you're supposed to do? So the standard error for p hat, of course, that's when we replaced p and q with p hat and q hat. All right, so here for homework today, you guys, we're out of the book, page 543. Let's do number 74, and I want that to be a write-up, and we'll only do that, we'll just do that one. And then also do 76 and 80, and we are done with chapter 8. So like I said, I'll have you turn in a write-up tomorrow, and we'll do some extra practice, like with, setting these intervals up, and then we'll start the official, the legit review on Wednesday. Test, I'm thinking Thursday and Friday in class. That's what I'm thinking for the test. Let's see how everything goes. All right, have a good day, everybody.